take a look at an example of exponential growth and writing an exponential growth function. So the first thing to know is what the form for an exponential growth function looks like. Well, it could take on a couple of different forms. The main thing to know is that when we have an exponential function, what we're doing is we are multiplying repeatedly. So we need to find two things. We need to find this value that we're starting with when x is 0, and we need to find the constant multiplier, the factor that we are multiplying by repeatedly. So we're going to begin by writing out f of x, or you could use y equals. A is going to represent the starting value, and b we're going to use to represent the constant multiplier, the factor that's being multiplied repeatedly. And since we are multiplying repeatedly, x is then an exponent because that's how we show repeated multiplication. So exponential growth could take on this form, f of x equals a times b to the x. And it's going to be growth just as long as b is greater than 1. And it needs to be greater than 1 because if you're multiplying by a number that's greater than 1 repeatedly, you're going to show that increasing in value. So let's take a look at what happens when we are multiplying repeatedly by a number greater than 1. So I'm going to start with a number, I'm going to start with 5, and I'm going to multiply that by a number that's greater than 1. So I don't know, 1.2 is greater than 1. When I multiply by 1.2, that increases to 6. Multiply by 1.2 again, and I've got 7.2, 8.64, 10.368, and that is just continually increasing because I'm multiplying repeatedly by a number that is greater than 1. Now what if I multiplied by 1? Well, here's starting out with 5 again, and I'm going to multiply that by 1, and I'm just getting 5 over and over. Because multiplying by 1 is just keeping the same value. It's not increasing at all. I'm just multiplying by 1 and keeping it the same. Now later on we're going to take a look at multiplying by a number that's smaller than 1, but just to see what happens, let's take a look now. So I'm starting with my value of 5, and I'm going to multiply that by a number that's smaller than 1, like 0.8. And now I have 4, and 3.2, and 2.56, and 2.048, and this is just continually getting smaller and smaller and closer to 0. And eventually it'll get very, very close, but never actually reach 0. So if you're multiplying by a number that is smaller than 1, but bigger than 0, you are going to see your values continually decrease. If you multiply by 1 repeatedly, nothing happens, it just stays the same. And if you multiply by something bigger than 1, your values are going to increase over and over, as long as you keep multiplying. So we're going to take a look at an example of writing a couple of exponential functions. So here's the first example. Orlando took out $24,000 in student loans to go to college, and each year the balance is going to increase by 6%. So the first thing I want to do is write a function that models the balance after X years, assuming he's not making any payments, and so he's not reducing his loan at all. So knowing that the form for an exponential function is equal to a times b to the x, or for percent increases, a times 1 plus the percent change raised to the x, we can approach it a couple different ways. The best way to approach this one, since it's a percent increase, is probably to just use this second form because that's the one that's sort of built for a percent increase. So writing this function out, f of x is going to stay f of x is equal to a is our starting value. Well, how much did he start out with his loan? He started with $24,000, so a is $24,000 times 1 plus, and we're going to use plus here because the balance is increasing by 6%, and so r is that percent rate, 0.06 as a decimal, and that's going to be raised to the x. So here's our exponential function modeling the amount of this balance over time. So my next question is, what will this balance be after 4 years? Well, what that means is that x needs to be 4. So what I'm looking for here is f of 4. What's the function value when x is 4? Well, that's 24,000 times 1 plus 0.06 raised to the 4. And if you calculate that, it turns out to be just about $30,299.45. So just to recap what we did with this function, we started out with these two forms, a times b to the x and a times 1 plus r to the x. And because this one involved a percent increase, it made more sense to use this form with the 1 plus r to the x. R, the rate, was 6%, so we wrote that as 0.06. And a, the starting value, is 24,000 because that was the initial value for his loan. Now here, x represents the number of years that have gone by, and f of x represents the amount of the loan. So when we wanted to find out what's the balance after 4 years, well, we made x4 and figured out what the function value is, and it's about $30,299.